que él viene de Londres. Les voy a dar su presentación. Él es un developer advocate en Google, entonces también es evangelista en Google, trabaja con desarrolladores. Actualmente está enfocado a facilitar el desarrollo con Google Cloud Platform como desarrollador con amplia experiencia en Java y recientemente en C#. Le gusta comparar ambos entornos de trabajo. Antes de trabajar para Google, formó parte del equipo de Microsoft, Skype, Adobe, EMC y Nokia, donde realizó aplicaciones y servicios para plataformas web, móviles y de nube. Originario de Chipre, actualmente vive en Greenwich, no muy lejos del primer meridiano.
All right, thank you. Let me get set up for a second. How do we show this over here?
¿Alguien nos puede ayudar en la cabina? Hola. Ahí viene alguien.
Yeah, there we go.
Listo. Pues eso es como permanencia voluntaria. Por el precio de uno se llevan dos ponentes.
Just one sec.
Bueno, yo sí quiero preguntarles, ¿quiénes de aquí son de la carrera de Ciencias de la Computación? ¿Uno? ¿Dos? No pasa nada. No juzgamos. Ay, sí. Dos. ¿Y de física? ¿Tres? ¿Y el resto de qué? ¿Cuatro? ¿De qué carreras son allá atrás? Ingeniería, ok. ¿Allá también? Ingeniería. ¿Tú eres de ingeniería también? Física. Ok, muy bien. ¿Y cómo se enteraron de la conferencia los ingenieros? Ah, ustedes trabajan con Marta. Ok, perfecto.
Okay, I'm ready, yes.
Okay.
Great. Hello everyone, my name is it working? Can you hear me? Yes. My name is Mete, I come from London. So I wasn't supposed to be here, as you might have realized. Because it was Wesley's time, and then he told me that he's speaking to some students, and I'm like, what is it about? And he said, G Suite. And I'm like, well, would they be interested in Google Cloud? And he said, yes, so that's why I'm here. So I'm not supposed to be here, you're not supposed to listen to me, but you're stuck with me for half an hour, 40 minutes. Hopefully it will be fun for you and you'll learn something new. So what I'm going to talk about is basically fundamentals of Google Cloud. So Wes talked about G Suite, but I will talk about the rest of Google Cloud. So you guys probably know Snapchat, right? You guys know Snapchat? Or Pokemon Go. These applications, they're actually built and running on Google Cloud. So what I want to talk about is basically what can Google Cloud provide to you if you want to build an application. And there's a lot of things, so I won't be able to cover everything, but I just want to give you the fundamentals so that you get the basic understanding, and then if you want to learn more, at least you know where to look for. So that's my goal here. All right, so back in the day, anyone knows about App Engine or heard of App Engine? Maybe? No? So back in 2008, Google came up with App Engine, and that's how Google Cloud kind of started. And the thing about App Engine is that we told people, if you use this programming language, which was Python at the time, and if you use it this way, which means use it in a restricted way, so don't access the file system, run it in a sandbox, stuff like that. And if you deploy to Google, then we'll make sure that it scales, right? So that was the thing about App Engine. So we gave you a model to stick to, and if you stick to it, then your application will scale infinitely, basically. So that was 2008. But what happened is that most people saw it, they liked it, but they didn't really use it because there was a huge gap between what people were doing and what Google wanted them to do. At the time, what people were doing was basically just regular machines running regular operating systems and maybe virtual machines, but they weren't ready to move to this App Engine world where everything is fully automated and fully scalable. So that's why since then, from 2018 to today, we've been building backwards. So App Engine is how we want people to build things, but then we are giving them other tools to bridge the gap between where they are and where we want them to be. So since then, we came up with Compute Engine, which is the virtual machines in Google Cloud. We came up with Cloud Storage, which is a way to store files in the cloud. And then we also had something called BigQuery, which is a way to analyze your data. But that's what we had in 2012. So it was pretty easy to understand. But if you look at today, this is what we have. So we have more than 80 services. So there's services for compute. So this is about how to run your application. This is about storing your application, storing your data. So databases, storage, things like that. Networking, big data. How do you ingest big data? How do you process it? Machine learning. So how do you use machine learning in your applications? Then identity and security, and there's even more. There's management, debugging tools, development tools, all that kind of stuff. So it's grown a lot from 2008 to today. So my goal is basically to go through these main big parts of Google Cloud and explain to you at the very high level what they are and what they can do for you. Oh yeah, and then this slide is about, all this choice is, on one hand, it's good because it gives you a lot of tools to work with, but at the same time, people get overwhelmed with this choice because if you want to run your application, you have compute engine, app engine, container engine, cloud functions. Which one do you choose? If you want to store your data, do you use a SQL database? Do you use a big table? Do you use data store? How do you choose it? So it can get pretty confusing, and hopefully this presentation will give you some guidelines on how to choose the right tool for the job. All right, so let's start with compute. By compute, I mean running your code. So you have a piece of code that you want to run, and what are the choices that you have on Google Cloud? So when it comes to compute, there are three distinct buckets, actually, and this is true not just for Google Cloud, but any kind of cloud. When you want to deploy your code, you need to think in these three buckets. The first bucket is called virtual machines. So if you're used to having your own machine, installing your operating system, installing the applications that you need on top, then when you move to cloud, you basically won't have your own physical machine, but you will have what's called virtual machines. These are kind of like regular machines, except they're virtualized, but you still get to pick and choose what kind of memory you want, what kind of CPU you want, what kind of storage you want. So you can customize pretty much everything you want. You choose the operating system that usually comes with the virtual machine, and then you install whatever you want on top, right? So it's fully customizable. So that's what people usually start with. Like if you're already running stuff yourself and you want to move to the cloud, the virtual machines is one way of doing that. But more recently, there's containers. Anyone heard of Docker, for example? Maybe, yes. So the idea of containers is that instead of virtualizing the whole operating system and everything that goes on top of it, you virtualize the actual process. So not the whole operating system, but just the process and the dependencies of that process. So your application and its dependencies are virtualized in what's called a container, and then you basically just run the container. The advantage of containers is that they're much smaller than virtual machines, so they're very easy to create, and they're very easy to move around and run them. And you can also run multiple containers on a single machine. So you can have a single operating system that can support usually tens of containers running at the same time, and they don't interfere with each other. So it makes it much easier to virtualize your applications. And then most recently, there's serverless. So the idea of serverless is that instead of dealing with virtual machines, instead of dealing with containers, you just deal with your code. You write your code, you define your input and output of your code, and you just deploy it to someone's infrastructure, in this case, Google Cloud, and let Google figure out all the details. So you're basically totally abstracted away from the underlying infrastructure, and that's the whole idea of serverless. And that's where the world is heading to, basically. The world is heading from virtual machines to containers to serverless, and more people are using serverless. So in terms of where people are today, I would say most people are either going from containers to serverless, or they're going from virtual machines to containers, but not many people are thinking in terms of virtual machines anymore, because maintaining virtual machines, it takes time and effort. Containers is much easier. Well, it's not easier, but it's more manageable way of running your application. So most people are in the container space, and they're trying to move to serverless if they can. But containers themselves, they're not enough, because when you run an application, you need resiliency. So that means you need multiple containers running at the same time. You need redundancy, and then you need resiliency, which means you need to have a health endpoint, and someone has to call that a health endpoint, make sure your container is running, and if it's not running, then it needs to create a new container. You need configuration management, all these things that you need around your container. So that's why we have something called Kubernetes. It's an open source container management platform. So that's what most people, when they make the switch to containers, they use Kubernetes on top to manage those containers, make sure that they are running. And most recently, there's also another open source project called Istio. Istio, it's a framework to secure and manage microservices. So you have containers running, and those containers are being managed by Kubernetes. And then on top of Kubernetes, you have Istio that's managing the microservices that you have. So you can do more high-level things. For example, you can say microservice A can talk to microservice B, but microservice A cannot talk to microservice C. Or you can set rate limits between your microservices so that microservice A can only call microservice B 5 times a second. So you can do all sorts of high-level things using Istio. So that's kind of like the landscape of containers and Kubernetes and Istio. Now, in terms of Google Cloud, so you have your code and you want to deploy to Google Cloud, the first thing that you need to decide is there's a spectrum of how things you want, so how customizable you want things to be versus how managed you want them to be. So if you want to have your own machine and if you want to be able to customize everything that goes onto that machine, then you will be on this side. But if you really don't care about customization and you just want to deploy your code and let someone run that for you, then you will be on the highly managed side. And by definition, the more highly managed things are, they end up being less customizable, and the more customizable they are, they will be less managed because it's custom, so we won't be able to optimize it for you. So on the highly customizable side, we have Compute Engine. Compute Engine is what we call virtual machines in Google Cloud. You can get a Compute Engine instance with Linux and Windows and with all the different flavors. You can specify the CPU you want, the memory you want. You can specify the storage that you have on the VMs, and then you just create, and then you have your virtual machine. You have total control on the virtual machine, so it's yours. So it's highly customizable. But on the flip side, you are responsible of it. So if you install some kind of software on top of the operating system, if the software needs to be updated, it's your responsibility to do that. Google is not going to do that for you. There's also something called Cloud Launcher. It's a marketplace for solutions to deploy to Compute Engine. This marketplace includes solutions from Google, but it also includes solutions from other third parties. So for example, if you want to build a Windows application, you need a Windows server, you need ASP.NET framework, you need IIS, you need SQL Server. There's actually a solution called ASP.NET Framework solution that you can search on Cloud Launcher and then just say, okay, deploy this to Europe West, and it will just find a Compute Engine instance and deploy it for you, but it's just one click, so you don't have to configure everything yourself. Everything is done for you automatically. So that's highly customizable. On the other end of the spectrum, we have Cloud Functions. So the idea of Cloud Functions is that you write a Node.js function, you define the input to that function, and you define the output as well. And then you also define what triggers that function. So that trigger can be an HTTP request, it can be a pub/sub message, so there's a queue that you can listen, and then if a message goes to that queue, it triggers your function. Or it can be a storage event. So if let's say you have a bucket where you store files, if you store a file, then it sends a message to Cloud Functions, and Cloud Function will execute the code. And that's it. So you define your function and then deploy the function, and Google manages that for you. Google manages everything about that function. It will scale it down to 0 when you don't use it. It will scale up to whatever when you need, when a lot of people are using it. It's fully managed. All you need to worry about is your code that you want to deploy. So these are the two ends of the spectrum. And then in the middle, we have a couple of things. The first one is App Engine that I talked about before. The idea of App Engine is it's very similar to Cloud Functions in that you define, in this case, an application, not just a function. But that application is managed. So you just deploy the application, and under the covers there are virtual machines that Google manages, but you don't actually have to worry about virtual machines yourself. So it's quite highly managed for you, but it's not a function. It's more than a function. It's an application. And then if you make the switch to containers, then there's Kubernetes Engine. So with Kubernetes Engine, with one command, you get a Kubernetes cluster. And then in this Kubernetes cluster, you can just say, give me a Kubernetes cluster with 5 nodes, and then schedule a container, and then Kubernetes will figure out where to schedule a container and run it. So it makes it really easy to get a Kubernetes cluster and schedule containers on the cluster. And then we have a couple of tools on top. We have Container Builder to build containers, and then we have Container Registry to store your containers. So because once you build your containers, you want them to be stored somewhere. And then once it's stored in a public place, you can actually deploy that container to either Kubernetes engine or App Engine or anywhere you want. So it makes it really easy to make your application really portable, and you get to choose where to deploy that application. All right, so that's the choices that you have in terms of when it comes to how to run your code. And keep in mind that when you are running your code in Google Cloud, you are running in the same network that powers search and Gmail and Maps and YouTube and all these products that have 1 billion users or more. So all the improvements that we put into the network to make these products great, they benefit your application indirectly because you are running on the exact same network. And that network looks like something like this. So it's a truly global network with lots of edge endpoints, and then it's fiber all over. So what we try to do is if your application is running in Europe and someone makes a request from some other place, we try to find the nearest edge endpoint, and then we want to get your traffic as soon as possible to Google's own network. And once it's in Google's own network, it's in private network. It's not internet anymore. So it's on Google's own fiber network. So because of that, the latency and throughput and everything, all the characteristics of network are really good. All right, and then let me just show you quickly Google Cloud Console. So this is the main console for Google Cloud, and then you'll realize all the magic is here. So all the products are here. So this is the Cloud Launcher that I talked about, the marketplace for solutions that you can deploy to Compute Engine. If we want to look at the Compute Engine, these are the virtual machines that I already deployed in my project. So you can see like I have a bunch of virtual machines. Some of them are stopped, so you can stop the virtual machines if you want, and some of them are running. This is a Windows one, so I can click on it and I can RDP into it, so I can remote desktop into it, or if it's a Linux one, I can SSH into it right from the browser. If you want to create a new instance, it's as easy as clicking Create Instance. And this will give you a page. You give your instance a name. You choose your zone. So there's a bunch of different zones, Europe and US and all that kind of stuff. But the thing is you can customize everything. So here I can click Customize. And then I can choose the number of cores. So these are the number of CPUs that I can have. So it's from 1 CPU to all the way to 96, which is crazy. And then you can also customize memory from all the way to 260 gigs. And then you can customize the boot disk. So this is the actual operating system that you can have. So by default, we have Debian, but you can have CoreOS, you can have Red Hat, you can have even Windows servers. You can even install applications. So if you want to install SQL Server, you can do it from here. So it gives you a really easy way to just pick and choose what you want, and then in the end you hit create, and then you have your VM running within like a minute or so. And just to show you the App Engine, so I also deployed an application to App Engine before. So this is the managed solution. This also, when I deploy my application to App Engine, it's still running on virtual machines, but to a user, it's transparent. You don't have to care about that. So in App Engine, you get a dashboard. So this is a sample application, so you don't see much input, but I have different versions, and then you can see some charts if the application is being used. Then you can also have different versions of your application. So in this case, I have 2 versions, version 0, and then version 5 is the latest version of my application. This is getting 100% of the traffic. This is not getting any traffic. If I deploy a new version, then it will have a new version as well. And let's say I want to split the traffic, because I want to do A/B testing with my different versions. It's very easy to do. I can just come here, split traffic. Then I want to use cookie-based splitting, and then I'm going to add a version. And let's say this gets like 40%. Hit save. Now it's updating the traffic settings. And then if we go back, we'll see that this is getting 60% of the traffic and this is getting 40%. So it's very easy. By default, everything runs on 2 instances. So this is 2 virtual machines, but it will be auto-scaled. So App Engine automatically scales up to 20 instances depending on the traffic that you have. So you don't have to worry about that. It's done for you automatically. So hopefully this gives you an idea of how things are. Oh, and then just to show you the cloud functions as well. So these are the small functions that you can write and deploy to Google Cloud. And I have a couple of functions, one from Sao Paulo that I deployed from Sao Paulo, and then one Hello World one. So this function is running somewhere in the cloud, but I don't know where it is. I don't know how it's been run. I don't care. This is the function, and you can even like test the function from here. I can trigger an event and say, let's say, I want to say message, hello Mexico. And test the function, and now this will find the function running in the cloud somewhere, and it will trigger it, and then once it triggers, I should see the output here. So that's how easy it is with functions. All right. So now let's talk about storage next. So how do you store your data on Google Cloud? So when you think of storage, it should be easy, right? Like storage, like we had disks before, now we have bigger disks, so it should be easy to figure out how to store things. But it's not actually that easy, because depending on your data and the way it's structured, that it gets quite complicated. So you need to think of things like, is my data structured data, or is it unstructured data? If it's structured data, do I store it on a SQL server, or do I store it on some other place? If I store it on a SQL server, is it going to fit on a single SQL server or not? And then if it's not going to fit on a single SQL server, do I need to have multiple SQL servers? If so, how many? And then if I need to have many SQL servers, then how do I divide the data? So do I need to find a sharding mechanism to divide my data? So there's all these questions that you need to ask. And if it's not structured data, then you need to use NoSQL databases. Which one do you choose? If it's binary data, what do you do? So there's all these things that you need to figure out. But thankfully, I hope this kind of answers most of those questions. So let's just go through it. Like, let's go through what options do you have. First of all, if your data is, it's transient data, so it's data that lives in the memory, but you don't really want to store that data because it's not that important, then there's something called Cloud Memory Store. So this is basically just a bunch of memory that you get, and then you can store whatever you want there, like the game state or user sessions, and then they have certain lifetime, and then when that lifetime is over, then they will be deleted. So that's for in-memory data. If you want to do relational data, you can use something called Cloud SQL. So Cloud SQL, it's managed MySQL. So it's the same MySQL that you might be using, but it's managed by Google Cloud. You can also have Postgres as well, managed by Google. So it's either managed Postgres or managed MySQL. And we're also working on having a managed SQL Server version as well. So it's basically having a SQL server running in the cloud managed by Google for you. There's also something called Cloud Spanner. So this is a SQL server that scales horizontally. And I'll talk more about Cloud Spanner later in the presentation, because it's a special product that not many cloud providers have. And if you want to do NoSQL, so if your data is not as structured, then you might want to use Cloud Data Store. So that's what most App Engine applications use. It's a way to store NoSQL unstructured data in the cloud. And if you have highly transactional data, so data that you need to read and write a lot, then there's also another NoSQL database called Bigtable. So Bigtable is really useful for highly transactional, unstructured data. And then if you just want to store objects, so just regular files, you can use Cloud Storage. Cloud Storage, it's basically a globally available storage solution. It can be based in a region, so you can say, I want to store data in South America region, for example, or you can make it globally available as well. So you can create a bucket that's available globally and store data there, and anyone accessing from different parts of the world, they will get data that's close to them. And if you want to have data in your virtual machines, you can have persistent disks, so there's bulk storage. So when the VM virtual machine starts, it will get a persistent disk attached to it, and then you can store whatever you want there. And then you can also take snapshots of that persistent disk so that you can use it to create other virtual machines if you want to. And then finally, there's BigQuery. So BigQuery, it's a data warehousing solution where you can ingest lots of data, and then you can run SQL queries against it really fast. So as part of that, it needs to store data, so we can think of it as a storage solution as well. But I guess when you're deciding on where to store your data, you need to think of how your data is structured. So if it's a structured data, then you probably want to use a relational database. So your options are either Cloud SQL or Spanner. So you would probably start with Cloud SQL because it's for smaller projects, but if you need to scale more than a single or two SQL servers, then you would switch to something like Spanner. And if your data is unstructured, then you can use data store for most of the applications. And if you are using Firebase, which is the mobile backend from Google, so if you are writing a mobile application, you usually use Firebase. And then in those applications, you would use Firestore, which uses data store under the covers. And then if you want to do highly transactional data, then you would switch to Bigtable instead of data store. And then, yeah, as I mentioned, cloud storage is a way to just store any kind of files to the cloud in a bucket. And then, yeah, Spanner, as I mentioned, is kind of like a special case, because when you think of SQL servers, the thing about SQL servers is that they give you the consistency that you need, but you cannot really scale them out. If you need to scale more than one SQL server, then you need to get into things like eventual consistency, because if you have two SQL servers running, and if you need to write to one, then you need to replicate that state to the other one, so it won't be strongly consistent. There will be delay in consistency. You need to deal with eventual consistency. So that's why most people start with SQL servers, but then at some point they switch to NoSQL, because with NoSQL, you can scale much more than a single SQL server. But with Spanner, you don't need to make that choice anymore. You don't need to make the choice between SQL and NoSQL. You can start with Spanner, and then Spanner, it's basically a SQL server service that can scale horizontally. That's the beauty of Spanner. And the reason why it can scale horizontally is that Google has atomic clocks, and it has this internal network that enables really fast synchronization between different nodes. So that's why you can start with a single node, but as you add more nodes, things still stay in sync. So it kind of looks like it is strongly consistent and always available, even though it might be unavailable at some time. So yeah, that's the story about Spanner. All right, so that's storage, and now let's talk about big data. So let's imagine that you have lots of data you want to process, and what are the options that you have on Google Cloud to do that? Anyone heard of MapReduce before? Yes, no? No one, okay. So back in the day, I think this was the beginning of the 2000s, there was a paper from people who worked at Google called MapReduce. And in this paper, we basically explained how to take lots of data and process them on multiple machines. Because if you can process data on a single machine, then it's easy. You just basically use a single machine, and that's it. But as soon as the data gets big, where it is not feasible anymore to process on a single machine, then you need to think about how do you break that data into smaller pieces, and how do you parallelize the work, and then once each machine does their work, how do you combine that work into one result, right? So that's what MapReduce paper explained. It gave a framework to people to parallelize processing of big data. It was a paper, and after that paper, there was a lot of other papers within Google, such as Bigtable, Spanner paper, Flume, Millwheel. So these were all either papers or internal implementations. For example, Spanner, it was a paper, and then we also implemented internally, and we've been using it within Google for a long time, probably for like 10 years. And we recently made it available to people using Google Cloud. But the point is that all of these, they were not accessible to people because they were either papers or Google implementations. So people reading these papers, they created these Apache projects. For example, Hadoop is the open source implementation of MapReduce. There's Spark for streaming processing. There's Pig and Hive. So all these papers, they kind of inspired this big data ecosystem within Apache. And because of the split in innovation within Google and within open source, we have two products. There's something called Google Cloud Data Flow, which is the way to process big data within Google Cloud. But then if you're already doing Hadoop and Spark clusters somewhere, you can take those clusters and bring that to Google Cloud using a product called Google Cloud Dataproc. So in Dataproc, you basically just say, give me a cluster or Hadoop, give me a Hadoop cluster of 5 nodes, and then you just run your job, and then the cluster will be created, it will run your job, and then when the job is done, the cluster will be torn down. So it's a good way of running big data jobs and not having to pay for it all the time, because you just pay for the time that they're running, and once the job is done, they will be brought down. So that's kind of like the landscape of big data processing and what we provide within Google Cloud to support that. But when you think of big data lifecycle, how do you process big data? There's a certain number of steps that you have to follow. The first step is capturing. So you need to capture the data, and there's many different ways of doing that. If you're using Google Cloud Analytics, for example, Google Analytics, maybe your web page is already capturing traffic, so you need to get that and send it to Google Cloud. There's Google Cloud Stackdriver for capturing logs and traces from your application. Maybe you're using PubSub, which is a public subscribe messaging, so maybe your application is sending messages. So there's all these different ways of capturing data in some way and sending it to Google Cloud. Once you have the data, the first thing that you need to do with the data is to clean it, because usually the data is not perfect, right? There's always some errors in the data or some outliers that don't fit with the data. So there's a product called Google Cloud Data Prep that makes this data cleaning much easier. So you pass your data to Google Cloud Data Prep, and Data Prep will look at it, and it will try to figure out whether you have outliers and whether you have some data that might not be right, and it will tell you, these don't look right, you want to fix them, stuff like that. So it helps you to clean your data, basically, and get it ready for big data processing. And then once you have your data, you need to process that, so you need to calculate something from the data, you need to measure something, or you need to aggregate data. For that, you would use Google Cloud Dataflow, and Dataflow supports two modes. It supports batch processing and streaming processing. So when you do BigQuery processing, you choose what kind of processing you want. You can do batch processing, which means you wait for all the data to arrive, let's say for a day, and once you have the data for the whole day, you run some aggregation on top of that. Or you want to do streaming processing, which means that as the data comes in, you calculate results as you go along. But Dataflow, it supports both modes, so you just decide what you want and then use Dataflow for that. So once you have the data processed, then you want to store it. So you can store it to cloud storage, or you can store it to a big table if you want, or you can store it to BigQuery storage and then use BigQuery to analyze it later. And then the next phase is analysis. So you have the data processed, you want to take a look at it. So for that, BigQuery is probably the one that you would normally use. Or maybe you want to feed your data to Dataflow again and do more aggregations on top. Or maybe you're using Spark and Hadoop, so you want to feed that into that. Or maybe you want to do machine learning. So you have the data and you want to do some machine learning analysis on top. So there's something called machine learning engine that will help you to do that analysis as well. And then once you have the final result, you want to visualize it. So for that, there's two choices. First is Google Data Studio. So this gives you basically some basic dashboards to visualize your data. For example, if you have geographical data, you can feed it to Data Studio and you can show it on a world map. But it's kind of limited. You know, you can show a lot of things, but it's limited. You can use their own dashboard to do things. If you want to be able to customize your data visualization much more, then there's something called Data Lab. In Data Lab, you use something called I think it's called Jupyter Notebook. It's a framework to write visualizations. So you can write those visualizations in Python, and you can use Data Lab to show them. So this kind of captures pretty much all the options, or most of the options that you have when it comes to big data processing. All right, and the last thing that I want to talk about is machine learning. So machine learning is becoming really big. It used to be much more academic before, but now it's becoming more mainstream because people have lots of data and they don't know how to deal with it, but they can use machine learning to make sense of their data. And also, all the tools and frameworks, it's making it much more accessible to the people. So you don't have to be an expert in machine learning to use machine learning, and that's a good thing. And if you look at machine learning usage at Google, this graph shows you basically the directories containing deep learning models at Google, and it's increasing exponentially from 2013 to today, and all these products at Google, in some shape or form, they are using machine learning. So it's becoming really big, not just at Google, but outside as well. So when it comes to machine learning, you have two choices. You can use machine learning in two ways. I call it the easy way and the hard way. The easy way is use someone else's pre-trained model. So you let someone figure out machine learning, and you let them train their machine learning model, and you let them give you an API for you to call. So what you do in this case is that someone builds a machine learning model and use an HTTP request to use that model. So that's the easy way of using machine learning. And if you can do this, then it's much easier to do than the other one. In the other case, you actually need to create your own machine learning model, and you need to serve it yourself. The reason why you might want to do this is because the model given to you might not be enough for you. Let's say it's a model for images, but you have some certain images in your field, and those images, they need certain labels. So this image model doesn't work for you. In that case, you need to actually build your own model and serve that yourself. So let's talk about the easy way first. So at Google Cloud, we have what's called machine learning APIs. These are models that we trained using our data, and now we're exposing those models to people to use in their applications. For example, there's Vision API, where you pass in an image to Vision API, and then it tells you everything about that image. So it gives you all the labels about the image, all the people's expressions, stuff like that. So we built a model for images, and you are just consuming that. There is Video Intelligence API, where you can pass in a video, and then we'll tell you everything about that video, the scenes in that video, the duration, all that kind of stuff. There's Speech API for speech. You pass in your speech, and it gives you text. And more and more. There's like natural language API, where you pass in some text or language, and it tells you the sentiment of that language. So whether that text is happy text or not so happy text. So it gives you the sentiment of the text. And we keep adding more and more APIs as we work on these models. So this is like the easy way of using it. And let me just show you an example of Vision API. So I have a demo. So let's pass in an image of a cat to Vision API. So what's happening right now is we have this picture of a cat, and we are passing that to Vision API running in the cloud. And then Vision API will send us back some JSON. So what you get back is this kind of JSON describing this image. And then here I'm just looking at this image in a graphical way. So what you get back is, I don't know if you can see, but we get back some labels, and Vision API is telling us that this is a cat, 99%. So it figured out that this is a cat. And then it figured out that this is an animal, 96%. And it even figured out that this is a British short-haired cat, 93%. So it gets quite detailed. And then it picked up the color in the image. So these are all the color ranges in the image. And it's also telling us whether this image is an adult image or spoof image or medical image or violent image. So if you want to do some kind of filtering of images, you can use Vision API to do that. If you pass in an image with text, it can extract the text. So for example, in this case, this is a traffic sign. So the Vision API is, it's a little bit slow. The Vision API is telling us that this is a sign, and it's a traffic sign, 90%. But then it also picked up the text, like these are the texts that it picked up from the image, and it will tell us where in the image this text appears. It picked up the colors as well, like before. If we pass in an image with people, then it will also detect people's expressions. So, for example, in this one, it's telling us that this is a social group, and there's some folk dance, which is nice. But then if I turn this on, face detection, you can see that it detected the people's faces, but not just that, but also their expressions. So this person, this is that person, is joyful. See, like joy is like high up. So it can detect whether people are joyful, angry, all the expressions from people. And the last thing I want to show you is a landmark. So let's pass in a picture of a field. So this is some baseball stadium, and then Vision API is telling us that this is a stadium, 98%, and it's a baseball ball game. So it's baseball, 93%. It picked up the text just like before. It picked up one person. So it's this guy here, it picked up that person. But then it also picked up something called landmark. So it figured out that this is a landmark, it's a known thing. And if we click on this, it will take us to Google Maps, and it will show us where it is. So we checked this earlier. So this is a baseball stadium somewhere in New York, but it will tell us, it will give us the coordinates. So all you have to do to get this kind of information is just pass in the image, and you get the labels, and from there you get all this information. All right. So that's the easy way of using machine learning, but at a certain point you need to build your own machine learning model because maybe the Vision API is not giving you all the information you need. Maybe you have your own custom images, so you want to use those to train your machine learning. So for that, there's something called TensorFlow. TensorFlow, it's an open source framework to write machine learning models and train them. If you look at the landscape of machine learning frameworks, you can see that TensorFlow is by far the most popular one. So if you want to learn one, this is probably it. And you can run machine learning TensorFlow everywhere. You can run it anywhere you want. It doesn't have to be in Google Cloud. But we have something called Google Cloud Machine Learning Engine that makes it really easy to run TensorFlow models, train them, and serve them, and create an API to serve them. So Cloud Machine Learning Engine basically abstracts away all the details of training and serving your models for you. So the way it works is that you can use G-Cloud command line tool and say, submit training, and then provide some parameters to your training. So this is basically submitting, this is basically like training your TensorFlow models on some machines in Google Cloud. And it will do this behind the scenes. You don't have to worry about those machines yourself. And once your training starts, then you can see the logs for it, so you can see the progress and how it's progressing. And then once it's done, you have an API that you can give to people to use. Just like Vision API is giving us an API to use, you can create your own model and then serve that API to other people. So in this case, there's versioning as well. So we have version 1, the default version, but then there's version 2. So that's the new one that we just created. And then you can give this link to people and they can use that model in their applications. So it makes it really easy basically to create, it's almost like a service. You train and then you serve it to people who want to use it. And lastly, there's something called tensor processing units. So we have CPUs for computation. We have GPUs for image and video and games for highly intense things. But then there's also TPUs, tensor processing unit, for training machine learning models basically. So these are specialized hardware that you can use in Google Cloud to train your TensorFlow models, and it makes it much faster than regular GPUs basically. It says 180 teraflops, but I don't even know what that means in terms of like GPU to CPU. So it's basically much faster than it would be on GPU. All right, that's all I have. So if you want to learn more, cloud.google.com is the page to go. If you want to try this out yourself, there's Code Labs. So here, Code Lab/cloud includes all the Code Labs that you can try on your own to test this stuff yourself on different kinds of parts of the cloud. There's also some official training on cloud.google.com/training. Oops, sorry. So there's the training link. And then lastly, if you want to use Google Cloud for free, there's a page that tells you how to. So there's cloud.google.com/free. So by default, you get $300 for free on Google Cloud that you can use it anywhere. But then there's also a free tier for Google Cloud. So all the services, they have a free tier that you can use forever free. So if you want to use Compute Engine, you get a one virtual machine for free all the time. If you want to use App Engine, you get a small instance for free all the time. So you can write a simple Hello World application or a demo application and run it for free on Google Cloud and see how it works for you. And with that, thanks very much. I guess we have time for a couple of questions, right? Yeah. So someone has a question, yep.
Hola, hola. Creo que sí. Ya. Sí. Hello, thanks for the explanation. One of the first concerns when you want to use cloud platforms is security, especially confidentiality of the information. For example, students' information. How this information is secured?
So when you use Google Cloud, for example, you create a project, and then everything lives under the project, and only you have access to the project, no one else does. And everything, all the traffic between clients and to Google Cloud and to the storage, it's fully encrypted, and you can even provide your own encryption keys. So only you would have the key. Even us, we won't be able to decrypt your data. So yeah, I mean, we take it really seriously because you are trusting your data with us. So there's no way we'll get in there and take a look or anything like that. And you can make sure that doesn't happen by having your own keys to encrypt the data. And everything is encrypted end to end.
Perfect. A second question is, if I want to use this Google platform for university projects,
Yep.
is there, without the free tier limitation, is it possible?
Yeah, there's a university program, right? I don't know in Mexico, but...
No, in Mexico it's not available. Right. So, no está disponible todavía en México el programa para Universidad de Cloud, pero de nuevo tienes $300 por un año. Además, todos los productos tienen free tier. Entonces, puedes utilizarlo hasta cierta cantidad tienes una cuota mensual. Si pasas esa cuota ya te cobran, si no la pasas puedes tener ahí corriendo tus aplicaciones, tus programas, el tiempo que quieras. La cuota así gratuita aplica más bien para los APIs, más que para Compute Engine y estas aplicaciones, pero creo que BigQuery sí entra, ¿no?, dentro de la cuota. Entonces, por ejemplo, BigQuery Machine Learning, entonces lo puedes utilizar gratis hasta cierta cantidad de datos.
Perfecto.
¿Alguna otra duda? ¿Pregunta? ¿No? ¿Comentario?
Bueno, les agradecemos a todos el haber venido. Igual les quiero agradecer al equipo de Google Cloud y de developers que nos acompañan y nos dieron esta conferencia para la universidad. Cualquier duda, tenemos los contactos de Mete y de Wesley. Entonces, cualquier duda que tengan, se pueden acercar a ellos cuando lo deseen. Gracias.
Stickers, if you guys want to come get a sticker.
I want to.